Now I think the stage is set to talk about, right?
Yes.
Drum roll, please. Orchestra comes up to now talk about glyphosate, which is better known as Roundup. And if people think Roundup is non-issue, well, Roundup is the most used herbicide in the world, and it's used heavily in the United States, so it's everywhere. It's on everything. A lot of people are aware that these GMO crops were created specifically to, I guess, endure glyphosate, survive it, but that's not the only crops that Roundup is sprayed on.
Right.
So essentially, Roundup, this glyphosate is ubiquitous. So for instance, if you're eating wheat and it's not organically grown and harvested, you are eating most likely wheat that was sprayed with glyphosate to make it brittle and easier to harvest. So it's in the wheat. If you're wearing cotton clothes, there may be glyphosate in your cotton clothes because that was sprayed with glyphosate. It's everywhere. Oh, one good news, maybe, I don't know if you saw this, the county of Los Angeles has told its employees to stop using glyphosate in county work, so in the parks and wherever else.
That's really, really great. Yeah, I had heard Miami as well, I think. Miami and Los Angeles are both stepping up to the plate. I think that's terrific. And I've seen some, a few years back even, there were some towns that were much smaller that were banning glyphosate in public places. That can really become a fire. I mean, we can get all these different cities across the country to follow suit, I'm hoping. Another bit of good news is the lawsuit. I don't know if you know about the new lawsuit.
I do know, but tell our listeners about it. It is a big deal.
Yeah, there have been 2 lawsuits now that have come through with a jury trial and with big awards for the plaintiff. In both cases, it was non-Hodgkin's lymphoma that was claimed to be due to glyphosate exposure. And the first case was in California, which was the Dwayne Johnson, and he was a groundskeeper for schoolyards, which really it gives extra weight to this whole story because he was using only glyphosate as a chemical to control weeds in the schoolyards of young children. So obviously the children are being at risk there as well. But he got non-Hodgkin's lymphoma in his 40s. He had young children. It was a real tearjerker, and the jury awarded him $289 million, I believe it was, which was later cut back to something like $68 million by the judge. And the second lawsuit just finished up a few days ago, and he was awarded $80 million by a jury for a non-Hodgkin's lymphoma. And he used only Roundup on his own property for decades, I think. He had been using Roundup himself on his property, and he developed non-Hodgkin's lymphoma, and the jury believed him that the glyphosate had caused his problem and that Monsanto was at fault for not letting him know that there was this risk, So Monsanto, and also for other shenanigans that they've been doing to try to hide the fact that glyphosate is a carcinogen. So I think this is really, really exciting, and there's a third lawsuit now already ramping up, so it's kind of a soap opera. I've been enjoying it. It's really given me hope that we may eventually be able to get this chemical banned worldwide, which is what my goal is. I don't think anything less than that is going to work, for the long-term survivability of the planet.
Absolutely, and we're going to talk about why this substance is so dangerous. But, my wife was at the store, the hardware store, one of the big hardware stores, getting something. And they already have their Roundup section all set up and shiny, and so people are using it on their lawns.
Right.
Their kids are running around on the lawn and absorbing it through their skin. Well, let's talk about glyphosate. What is this stuff? It's designed to kill plants.
Mm-hmm. Right.
I sent you an email about this a while ago, and you responded, but I had found this thing called glyphosate.ca. I think it was some Canadian website for Monsanto. And they basically said how wonderful that we have this absolutely, for the first time in human history, we have an absolutely safe herbicide. Heavens, how wonderful. Tell us how nonsensical that is.
Yeah, and when you get an email from someone who says they've got several $1 million and all you have to do is reply, it's too good to be true, right?
Right.
People should wonder about that because glyphosate is very proudly claimed to kill all plants except for those that have been engineered through a bacterial gene insertion through GMO technology to resist it. And yet it's completely and utterly harmless to humans. And there's something there's something fishy about that, How can something be so toxic to plants and then completely harmless to humans? It doesn't make sense. Because it's a great herbicide in that respect. It's actually, many herbicides specialize in only certain plants. And so you have to take, different herbicides to kill different plants. One thing great about glyphosate is it kills everything. So you don't have to worry about which kind of weeds you've got. You just throw it on there and everything's dead. Very scary,
How does it kill plants? By what mechanism does it kill all? I mean, it kills all.
Yeah.
How does it do that?
So they've targeted a specific enzyme as being especially susceptible to glyphosate, a very important enzyme in plants, which is called EPSP synthase, and it's an enzyme in a biological pathway called the shikimate pathway. And the claim is because we don't have the shikimate pathway in our cells, then our cells are immune to this product. It's a nice story, very appealing. But unfortunately, so one thing is that our gut microbes do have the shikimate pathway, and they use it to produce molecules that are essential for us because we can't make those molecules. We can't make them because we don't have that pathway. We depend upon our gut microbes to make those molecules for us. And those molecules are the aromatic amino acids, which are the building blocks of proteins. And proteins, of course, are absolutely essential for life. So when we eat glyphosate, our gut microbes are unable to keep up the supply of those aromatic amino acids, which has lots of consequences to our health. That's just one thing to think about.
If I may, let's unpack that a little bit for people, because some of this might be brand new information. So we eat food, and it goes in our mouths, and it goes down the esophagus, and in the stomach. It gets bathed in acid. It ends up in the small intestine, gets a little help from the liver and the gallbladder, and then it ends up in the large intestine, and then we get rid of it. In our guts, we're talking about the small intestine. Is that the area we're talking about?
Well, yeah, really the entire intestine has the gut microbes, but I suppose the large intestine is where most of the microbes are.
Oh, in the large intestine. Okay. And so we have in our bodies lots of good microbes, and they are like little engines, basically, that take our food and break it up into parts so that we can reassemble it and live. Is that pretty much what's going on down there?
Yeah, I mean, they are really fancy. I mean, the gut microbes have, their collective genome is over 100 times more information, contains more than 100 times more information than our genome. We're actually pretty pathetic compared to the rich space of enzymes and whatnot that these microbes have that they can bring to bear on the problem. So we depend upon them to do things that we can't do because we don't have the appropriate machinery to do it.
So they do the work of turning the food we eat into substances that we can actually use.
Right. I mean, we obviously contribute as well. We have digestive enzymes, but I think they are a huge contributor. And they also produce things for us, such as folate, for example. Folate comes out of that shikimate pathway, and that's this B vitamin that is associated with birth defects if you don't have enough in pregnancy. That's a product of the shikimate pathway as well, and that's going to get disrupted. So they make B vitamins. They just make a lot of essential things for us that we can't make ourselves.
And there's one other class of chemicals they make that I think it's really important for people to know, which is the neurotransmitters.
Right. They come out of that shikimate pathway, all of them, and also thyroid hormones. So serotonin, melatonin, and also the skin tanning agent melanin. I wonder about melanin being deficient and therefore causing a sensitivity to sunlight, developing sunburn because of melanin deficiency, because that comes out of the shikimate pathway as well. And so thyroid hormone, we have a lot of issues with thyroid these days, which I suspect may be connected to that as well. So there's just so many. Those aromatic amino acids are precursors to all these other things that are really, and the neurotransmitters are super important in the brain. Dopamine, serotonin, melatonin, epinephrine, all those things come out of the shikimate pathway.
For instance, without serotonin or a shortage of serotonin, life is really miserable.
Right. And it causes depression, it causes violent behavior, it even causes obesity, shortage of serotonin.
And then the melatonin. Without melatonin, you're not going to be able to sleep.
Right, and we have an epidemic in sleep disorder that's going up exactly in step with the rise in glyphosate usage on core crops.
So all these. So when we talk about our, because generally we're not educated very well in school about science or about medicine or about health, and we're not told that our guts are. Somebody made it so clear. Is this a clear image that if you think of a human being and you compare it to a tree, for example, the guts occupy the place of the roots.
Mm-hmm, that's right.
So if you remove the roots of a tree, it's all over.
Right.
And for that tree. And if you damage what you call the gut biome?
Microbiome,
Microbiome. If you damage that, it's the equivalent of carving up or chopping up the roots of a tree. It's very, very, very significant. So the health of our internal guts, the health of our microbiome in our guts is not a trivial matter. It's not a, something we can worry about next year. It's like it's absolutely dependent. We're absolutely dependent on it for health and survival.
Right, and in fact, of course, people are more and more realizing that many of these neurological diseases are actually, they start in the gut. You get trouble with the gut, and then the gut-brain axis. There's tremendous communication between the gut and the brain. And when the gut becomes harmed, the brain responds, and you end up with neurological diseases. It's very clear.
And the gut has actually been called a second brain. It's
right.
that important.
And some people even call it the first brain because they think it's so important that the other brain is secondary to it. Yes, absolutely.
Well, it might be, because if you're not nourished and you're not eating, if you're eating, but if you're not nourished properly, you're not going to be able to get a whole lot done. You can always think later after you've been nourished, but nourishment doesn't take place.
Well, an interesting thing is that bifidobacteria are extremely sensitive to glyphosate. So one of the things that happens with chronic glyphosate exposure is that your gut gets out of balance. And bifidobacteria and lactobacillus are super important in the very beginning of life. Those are the microbes you need to digest the milk that you're getting as an infant. And they have been shown in studies to be very sensitive to glyphosate compared to some of the other species. And species like Clostridia and Staphylococcus, some of these pathological species are less sensitive to glyphosate. And so what happens is that the bifidobacteria reduce their number in the gut because they're getting killed, and these other microbes have an opportunity to flourish. And so you get pathogens invading, and then you get the immune cells responding, and you get inflammatory bowel disease, which is an epidemic right now that's going up exactly in step with glyphosate usage on core crops. So we have a lot of issues with the gut that are showing up because of this exposure to the microbes.
So Roundup, glyphosate, was specifically designed to disrupt the shikimate
pathway, yeah. And what they're overlooking is that the gut microbes are sensitive to glyphosate, and that it's very important to have the right balance of gut microbes in the gut, which is being disrupted. Glyphosate's acting as an antibiotic, basically. It's like you're chronically taking a low-dose antibiotic that's killing off your microbes and disrupting the balance.
And of course, antibiotic use is also going to disrupt the gut functioning and the flora.
I believe glyphosate is a major player in the problem we have with antibiotic resistance right now, because it was a wonderful paper that showed that when you expose these microbes to glyphosate, they actually are smart, and they develop an efflux pump that can pump the glyphosate out, but it turns out it more generally can pump out other antibiotics as well. So they find that when the E. coli, for example, which are a very common microbe in your gut, when they're exposed to glyphosate, they become empowered to be resistant to other drugs like penicillin. And so you end up with this problem with antibiotic resistance that we're confronting right now.
Okay, so to sort of do a quick review here, so Roundup and glyphosate were specifically designed to disrupt the shikimate pathway in plants. They don't deny that. That's what the plan was, and that's why it works so well. Then they said, but hey, don't worry, you're not a plant.
Right.
So it's not going to bother you. And they conveniently overlooked the reality that's not debatable, it's not disputable. The reality is that we depend on plant-like beings in our guts to do all of the processing of our nutrients, or a lot of the processing, and to create the neurotransmitters we need to be able to function mentally, and so on. And those are affected by glyphosate.
Right.
Okay.
And it's actually been patented as an antimicrobial agent.
Really?
So it kills microbes, yeah.
So the only way this scam, because it really is a scam with a capital S and all capital letters, the only way this scam works is through the ignorance of people. And I'm not blaming people for being ignorant. They've been made ignorant deliberately by billions of dollars in advertising and government misrepresentation as well. If you just understand that we are 100% dependent on the health of the biome in our guts, and that those beings are killed, disrupted, destroyed, undermined by glyphosate by design, because that's what it was meant to do. It was meant to destroy that pathway.
Right.
So it's doing exactly what it's designed to do, except it's doing it in the guts of human beings. And this is not a matter of a little indigestion or a little acid reflux. We're talking about the very root of your health is being undermined by glyphosate.
Right.
And why you and I have to even talk about this on a podcast, and why it hasn't been banned why it was ever even allowed to be, 1 gram of it was allowed to be put into the general public is a mystery. And yet, at this moment, as we're talking, this is the number 1 herbicide being used in the U.S. And as I mentioned earlier, if you go to any hardware store, you're going to see a stack of it, and everybody's coming in and buying it and spraying it all over the place. Mm-hmm. So that's the bad news. Now, the other thing that this myth-creating site, glyphosate.ca, said is that, oh, it's so great it breaks down very readily into perfect substances. Tell us about the reality behind that.
Right. That's not true either. I mean, they say that it'll disappear in a couple of weeks and it'll get broken down by microbes in the soil and it'll be gone, and that's wonderful, And whereas, in fact, the truth is that it can survive for years in certain conditions. There's only very few microbes that can break it down. And so if those microbes aren't present and, certain kinds of soil types, the glyphosate just sits there and doesn't go away. So it's not true that it disappears quickly. And in your body, too, they say it just goes in and goes out unmodified in your body. That's not true either. A small percentage of what you eat ends up in your tissues. And they know that because Monsanto's own experiments have shown that. And what's interesting to me is what I believe is that it ends up in your tissues in the form of embedded in the proteins of your body. And this is something that concerns me very greatly, and it's something I've become very obsessed with, which is this idea that glyphosate has another mechanism of toxicity that's insidious and cumulative, and this involves getting inserted into proteins by mistake in place of the amino acid glycine. And if this is happening, it has huge consequences that are incredibly terrifying. And I believe it is happening because the more I look, the more it helps to explain all the various diseases that are going up dramatically in prevalence in step with the dramatic rise in the use of glyphosate on core crops. I think that correlation maps to a causative relationship. The glyphosate is causing those diseases to go up.
Yeah, so Bayer, because that now owns Monsanto, it's inherited this monster, but we'll say Monsanto. Monsanto told us, oh, it breaks down in the soil and water. Not true. It accumulates. The next lie is, oh, it passes through your body untouched.
Right.
False. It actually gets embedded in the tissues of the body. And then you pointed this out. I think I want to make sure everybody grasps this. We're made of protein, right?
Right.
Okay? And proteins are, amino acids, right? Mm-hmm. Basically put together into various forms. Is that what a protein ultimately is?
That's right. It's a string of amino acids. They're hooked together like beads on a string.
Okay, so we're made of protein. That's us. Without protein, we are nothing, or we are very sick. And the proteins are made by amino acids. That's the building blocks. And now here's where it gets really scary, and everybody should pay close attention, and so that you fully understand why glyphosate is not a trivial thing. It's very frightening. It seems to be able to masquerade as an amino acid, as the amino acid glycine. And what Dr. Seneff is saying, just so everybody, I'm just repeating it. She said it. I'm just going to say it again because I want to make sure everybody grasps this. It appears that glyphosate is getting into the actual building blocks of protein and embedding itself permanently.
Well, I mean, that's a big question. I think that once there's glyphosate in there, it's very difficult to break the protein down. Because glyphosate, the enzymes that break it down don't expect to see glyphosate, and they don't know how to get it out. So I think it stays in those proteins, and especially where you've got the sulfate deficiency problem, you can't break down proteins anyway, or you're deficient. And so I suspect it sticks around for a long time in certain proteins, possibly for your entire life.
When we're talking about proteins, we're talking about the structure of our very bodies.
The proteins are the workhorses of the body. They're the enzymes, the receptors, the ion channels. I mean, they're all proteins. Proteins are really, really important in the body.
Got it. So we've basically got deranged proteins,
yes.
Would we call them?
Deranged proteins is a very good word.
And if your liver isn't working, or your heart isn't working, or your brain isn't working, or your muscles aren't working, the cause could possibly be that you've got some deranged protein that's the result of glyphosate being taken in instead of glycine.
That's exactly what I think. Yeah, and I think it's happening throughout your body. And depending on your genetics and depending upon your diet, it's going to affect you in different ways. But everybody's going to get sick eventually in different ways. We're all being poisoned.
So that's where we're at. Now, interestingly enough, there is a substance called chlorine dioxide, which is, I guess that means one chlorine atom and 2 oxygen atoms.
Very good. That's right.
I have to say, chemistry was not my best subject in school, but I'm now trying to do some remedial chemistry. And before we look at that, let's look at this dihydrogenous
Dihydrogen oxide.
Dihydrogen oxide, I think, to me, sounds like a very dangerous substance that needs to be handled carefully. You should wear special gloves and a special face mask, and of course you certainly wouldn't want to get any of it on you or in you, but it's H2O, which is water. And the reason I say that is if you don't know any chemistry at all, or you know as much chemistry as I know, which is almost nothing, just hearing the name of a chemical makes it automatically sound dangerous. So chlorine dioxide, oh my God, chlorine, I know that's bad. Tell us just at a raw level, let's pretend it's chemistry 101. Chlorine dioxide, what is it? What is it made out of? And
yeah, so obviously it's chlorine and 2 oxygens, and it's a neutral charge. And I think when they prepare it, they mix it in with citric acid or some kind of weak acid, which is what activates it. So in chemistry, there's all these small molecules in biology that are reactive and that are extremely useful to biology because they can make things happen. They can make reactions take place. The body has to have these things in order to be able to function. And people hear about reactive oxygen species and reactive nitrogen species. These are small molecules like chlorine dioxide that are reactive. And I mentioned sulfite, for example. Sulfite is very reactive. Sulfate is essential. And there's only one extra oxygen distinguishing those two. So it's really interesting that different molecules have different degrees of reactivity. And the ones that are highly reactive are powerful because they can do things. But they're also dangerous because they can do things you don't want them to do. So there's always that dilemma of how to get these things where they need to be and get them to do what they need to do without causing collateral damage. That's a danger with all. And of course, oxygen is actually very reactive, very dangerous. When you see anybody shipping oxygen, they've got these very thick tanks, walls of the tank on the truck because it can explode and cause a fire. These chemicals that are very reactive are potentially dangerous. There's no doubt about that. But they have tremendous benefit if they can do something that nothing else can do. And that's where I think chlorine dioxide becomes very distinct, unique ability that it has that very, very few other molecules have.
And mentioned it's made up of 1 atom of chlorine and 2 atoms of oxygen. That's what it's literally.
Right. Of course, it's a natural molecule. It's not a synthetic. That's very important because I think the synthetic molecules they make in the chemistry lab are the most dangerous in general, because biology doesn't know how to deal with them. It's not used to seeing them. Whereas chlorine dioxide reacts and produces different products, one of which is hypochlorite, which I suspect is its big, strong strength, that it produces hypochlorite, which has, for example, the immune cells produce hypochlorite. It's something that's naturally produced by the immune cells when they're fighting infection. So if your immune cells are cobbled by glyphosate, they may not be able to produce enough hypochlorite to be able to control those pathogens that are growing. And so if you were to provide yourself with additional hypochlorite, you could help the immune cells to clear the pathogen.
Okay, this is really important. So hypochlorite?
Mm-hmm. Hypochlorite.
Hypochlorite.
Yeah.
And this is something that the cells produce themselves in order to deal with pathogens and
Right.
other things that they want to get control over. And chlorine dioxide is a precursor to that?
Yes, exactly. When it breaks down, one of the things it produces is hypochlorite.
Got it. Hypochlorite is a byproduct of the breakdown of chlorine dioxide.
Right. And it's probably the reactive element that would be the one you'd worry the most about. But the fact is the body knows how to deal with hypochlorite because the immune cells can make it, and they know how to deal with the collateral damage. Actually, that's a very interesting chemical process in itself because there's another molecule called taurine, which is a sulfonated amino acid. It almost has a sulfate. It's got something that's sulfide attached to it, so you only need 1 extra oxygen to make sulfate out of taurine. If you react taurine with hypochlorite, you produce something called taurine chloramine, which is actually more reactive. Taurine is pretty inert, but once you put the hypochlorite there, it makes the taurine able to provide sulfate. So I believe that the hypochlorite I believe there's 3 reasons why it's effective. One is it's helping the immune cells to fight the pathogens. And 2, it's helping taurine to get turned into sulfate, which is a job of the microbes in the gut. They provide sulfate for the host from taurine, and I suspect that hypochlorite helps them to do that. So you're getting additional sulfate, and you're getting control over the pathogens, and it's one of the very, very few reactive molecules that can fully break down glyphosate non-enzymatically, and I think that's absolutely crucial for its success. It clears glyphosate without even using enzymes.
So let's really focus on this. So, and I have to apologize to you and everybody else. My ability to understand how to say these chemical terms is very limited. So hypochlorite, or I'm going to write that chlorite.
Hypochlorite,
Okay.
HOCl-.
Okay, hypochlorite. This is a natural substance. It's used to fight pathogens. It's used to help convert taurine into sulfate.
Yeah.
Okay, which is, we've already talked about how important sulfate is, but
Right.
you just mentioned something really important. I mean, they're all important, but it can break down glyphosate.
Right. Non-enzymatically.
Non-enzymatically. Now,
It doesn't require an enzyme. It just does it. Because it's so reactive, it can do it, which is great because, as I said, very few things can. The only two chemicals I'm aware of that can do it non-enzymatically are ozone and hypochlorite.
Okay, so great. Let's make sure everybody can really wrap their minds around this. So chlorine dioxide is a precursor. When we say precursor, that's the one part of chemistry I do understand. It's the something that comes before the something else.
Right, that's
right?
a nice word.
Right? So chlorine dioxide is a precursor for hypochlorate. Hypochlorate is what the cells manufacture all day long to deal with the pathogens that we encounter every day. It's also essential for converting taurine into sulfate, and we've already talked about how important sulfate is. But now, it, along with ozone, hypochlorate, are the only things that you know of right now that can deal with glyphosate.
Non-enzymatically. So there's enzymatic action as well, and that's also super important, and that's why I think vinegar is so useful. I recommend Bragg's organic apple cider vinegar, unfiltered. So vinegar with live microbes, those microbes, vinegar has a lot of acetobacter, and acetobacter are among the very few microbial species that can break down glyphosate enzymatically. They have the enzyme that can break glyphosate down. There's what's called a CP bond in glyphosate that's very, very difficult for biological systems to break down. And so there's only these few microbes that can do it, and acetobacter is one of them. That's in apple cider vinegar, it's in sauerkraut, kombucha, kimchi, sort of all these fermented foods. Fermented cabbage, of course, is super because you've got the sulfur as well. These are super healthy foods to eat, again, for the goal of breaking down the glyphosate.
Wow, this is so incredible. So when we talk about enzymatic, we're talking about living things, and you can get the enzymes that you need to begin to deal with glyphosate from naturally made sauerkraut, naturally made kimchi, naturally made apple cider vinegar. And so there's a difference. Maybe you could explain to people, there's factory-made sauerkraut, which may not even be sauerkraut at all.
I know. You have to worry about sauerkraut being too processed to the point where they've killed off the microbes. So you want to have sauerkraut that's hasn't been processed through some kind of microbial killing operation to make it so that it'll last forever and not have anything good in it, So.
Right. So luckily you can nowadays. And this wasn't the case even 10 years ago. I remember going to a long time ago. I went to a workshop on how to make your own real sauerkraut, and I thought, gosh, why can't we buy this in the store? Well, now we can. Pretty much every health food store is going to have a section with reliable sauerkraut, and so that's the enzyme way, the living way to get rid of glyphosate or to help manage it.
Yeah,
but now
those are your only two choices for breaking it down as far as I'm concerned, either enzymatically or through things like hypochlorite that are so reactive they can break that bond even without any enzyme.
Got it. And hypochlorite is something that comes from chlorine dioxide.
Right.
Okay, so now we've been told by a cast of dubious characters that chlorine dioxide, which is the precursor to hypochlorite, which is the thing we absolutely need to survive and which also helps us deal with this serious toxin of glyphosate. We've been told that chlorine dioxide is dangerous, it's bleach, it's torture to give it to somebody. Tell us your thoughts about that.
Right. Well, so I think it's true, if you were to take a lot of it, you'd be in trouble. It would definitely, because it is very reactive, so you do have to be careful with it. But I think that by taking it in very small amounts and then several times a day in very tiny amounts, I think that is an interesting way to try to cope with getting rid of glyphosate. And, of course, all the other benefits that it has. So as long as it's, because your body is producing it, it's just a matter of anything that is good for you can be toxic in larger amounts. So it's just a matter of being careful.
Water is toxic if you get it in your lungs.
Yeah, and you can just drink too much and die from it, too.
Yeah, and table salt and So
exactly.
When we talk about toxins, we're really talking about the size of the dose. It's always the size of the dose. And again, and we should point out that the idea of trace amounts is clearly understood by big pharma and the government and the news media that supports them, because they're telling us that trace amounts of mercury in the bloodstream of infants is perfectly fine. Don't worry about that. Yeah. Don't worry about the aluminum. That's no problem. But oh my God, this chlorine dioxide, oh boy, you can't get anywhere near that.
Right.
So
and
you're saying
that if a child is swimming in a swimming pool that's using chlorine as an antimicrobial agent, and if they drink the water in the swimming pool, you're not going to let your child not swim in the swimming pool because they might drink that water. And that's essentially, the same thing, right? People don't.
It's much stronger too. I mean,
I know. Right.
This is an important point. Let's make sure people understand this. There's chlorine that they use in pools. There's Clorox that they use, to clean. This is a different thing. Chlorine
They're
dioxide.
all kind of connected to the chlorine thing. I mean, they're all sort of reactive chlorine, but the thing is that small amounts are not going to harm you, and we're not afraid of it if it's in a swimming pool. So that's kind of inconsistent with being afraid of it if you take a little bit in a water dosage.
But for instance, we don't spray the chemicals used in a pool. We don't spray those on vegetables. I don't think. Maybe we do.
Yeah.
But chlorine dioxide is sprayed on vegetables. It is sprayed on chicken.
Yeah. And also you can get it to if you're going to be traveling in the woods and you want to have some water and you want to make sure you want to use the water, you want to make sure that it doesn't have some kind of nasty microbe in it. You can buy something that you put a few drops in your water to treat it, and then wait for it to react and then drink it. So if you're willing to do that, you're willing to take the risk, right? And these things are available on the market.
Yeah, I mean that's something everybody should know, that this supposedly deadly substance is sold in sporting goods stores and used every day, has been for decades, to purify water that otherwise can't be purified. But this is a total sidebar, but just by amazing coincidence, I talked to a friend of mine who accidentally, as a child, years ago when she lived in Iran, ate 2 of those tablets that you're supposed to use for the detoxifying the water. She ate them straight.
Wow.
It wasn't pleasant, but she survived to tell the tale. Now, we're not encouraging people to do that. There's no need to do that.
I know. With anything that is reactive, you have to be careful. That's clear,
When you say reactive, just so people know, what does it mean when one says something's reactive?
I mean, it basically breaks molecules down. It changes them. It reacts with other molecules and changes them. And that's the thing with the chlorine dioxide. It provides, electrons that are going to react with things and cause molecules to change. And that's what you need with the glyphosate. You need to be able to break that bond between carbon and phosphorus. And chlorine dioxide can do that. Once it becomes hypochlorite, it can do that. It can break that bond. And once you break that bond, the rest of it's easy as far as breaking down the glyphosate is concerned.
So chlorine dioxide, in addition to the fact that it does kill pathogens, viruses, biofilm. Biofilm's a big deal. That's sort of the slime that grows on water pipes. You don't really want that, and chlorine dioxide is used to eliminate that. In addition to all those other things, it's reactive in that it's able to disassemble glyphosate. What's glyphosate made of? How is glyphosate constructed chemically?
They make it in the chemistry lab. No biological species is willing to make that molecule because it's too toxic, I expect. But it is made in the chemistry lab, through processes that involve glycine, I suspect, as a precursor. I don't know the details. But
the molecule...
It's a glycine molecule. It's a complete glycine molecule, except glycine is the simplest amino acid. It has no side chains. So a very small molecule. And then it has the extra material stuck onto its nitrogen atom, which is this CP bond. So a carbon is stuck onto the nitrogen, and then there's a phosphorus attached to the carbon. And then there's oxygens attached to that phosphorus to make this phosphonate with 3 oxygens and a phosphorus and a carbon. All that piece is stuck onto the nitrogen atom of the glycine molecule. It's a pretty simple chemistry. It's not chemical, but
gotcha. So
synthetic.
So when you break up the glyphosate molecule, what does it break up into?
Well, what happens with the hypochlorite is the carbon and the phosphorus come apart, and that's crucial. That's like the first step, and that's what the enzyme does too, break the carbon and the phosphorus apart, because those two really like to stick together. They're very difficult to break apart. And once you do that, then you've got this phosphonate that can easily be turned into phosphate, and that becomes a source of phosphate as a nutritional source. And the rest of it is just something called sarcosine, which is an amino acid, not a coding amino acid, but an amino acid.
Is that easy for the body to eliminate?
Yeah, sarcosine is a regular, normal thing that the body makes, the body uses. So it's not a problem at all. Both of those are perfectly fine. Once you break that CP bond, you've got things that are perfectly fine.
And the CP bond is the carbon plus phosphorus.
Yeah.
Is the body able to use the carbon and phosphorus?
Absolutely. Once the sarcosine and the phosphate are available, they can be used to build other materials. Yeah, they can totally be useful to the body.
So literally, hypochlorate, which is created by chlorine dioxide, is able to take the glyphosate molecule, which is toxic, very toxic to human beings in practice and reality, and it's able to convert it, break that molecule down into harmless, not only harmless, but in some cases useful substances.
Right, exactly.
So small amounts, and we're talking about, a few drops in a glass of water consumed over the course of a day. That's a low dose, obviously, of chlorine dioxide.
Right, and you can see testimonials on the web, and I've looked through them, and it's just amazing what people are finding. And people are finding using it as a mouthwash can help to clear up tooth abscesses and things like that. They can really straighten up gum problems because, again, it's antimicrobial. People are finding miraculous results, I think, from using it in very small doses.